Okay, now we try to solve question 6. We are given figure 4, show an RC circuit. So we have a capacitor connect in series with a resistor and also a switch and a battery. Okay, if the capacitance and the resistance is 0.4 microfarad, so our capacitance is 0.4 microfarad and the resistance is 10 kilo ohm. Respectively, calculate the time taken. We want to find the time taken for the charge to reach 70% of its maximum value and plot the graph of Q versus T. So we have two questions. First, we have to find the time for the charge to reach 70% of its maximum value and plot the graph of Q against time when the switch is closed. So class, when we close the switch, we know that our capacitor and resistor is connected to a battery. So the presence of the battery in the circuit, means the capacitor is connected to the battery. It will telling you that we are going to charging the capacitor. So we are going to charging the capacitor. Okay, so the capacitor will get charged. So we want to find the time taken for the charge to reach 70% of its maximum value. So class, if you refer to our notes, during the charging process of the capacitor, we will find out that our charge will increase exponentially with time. So for this question, we know that because it's a charging process, so my charge will increase exponentially with time until it reaches a maximum value of Q0 . So the question asks us to find the time taken for the charge to reach 70% of its maximum value. So I want to find what is the time? For the charge to increase to 70% of its maximum value. The maximum value I denote by Q0. Okay, maximum value I denote by Q0. So I want to find how much time I need to taken. How much time is required to reach 70% of the maximum charge. So we know that this curve can be represented by equation Q equal to Q0. Okay, so if you refer to your lecture notes, this curve you can represent with the equation Q is Q0 in bracket 1 minus e to the power of negative t over RC, where Q0 is CV0. Okay, so I write it down. So Q will be Q0 in bracket 1 minus e to the power of negative t over, t over RC. Okay, so I use this equation to find the time. So I have this one, Q equal to Q0 in bracket, Q equal to Q0 in bracket 1 minus e exponent to the power of negative t over RC. So I want to find the time. So class, I want to find the time when my charge is how much? When my charge is 70% of Q0. So I put it in. So the charge is 70% of Q0. This is how we write in mathematics. 70% of Q0. Okay, then this one is Q0. 1 minus e negative t over. So the value of R is 10 kilo times 10 power of 3. The value of capacitance is 0.4 to the power of negative 6. Okay. Then I have 70 over 100 is 0.7. Q0. 1 minus exponent t over, minus t over. So this value when I do calculation is 4 to the power of negative 3. Okay, now I stop using mathematics. Q0 and Q0 can be cancelled. So I'm going to have 0.7. Another side we have 1 minus exponent to the power of negative t over 4 to the power of negative 3. So then I move the exponent to this side, so the negative will be cancelled. So I have negative exponent to the power of negative t over 4 to the power of negative 3. I rearrange the equation. So 1 minus 0.7, I get 0.3. So then I ln both sides. Okay, in next we call ln both sides. I ln both sides of equation. Why I need to ln both sides of the equation? Because in order to get the value of t, because the t is inside the power of exponent. So I have to ln both sides. Okay. So when I ln both sides, I am going to have the power tu akan bawa ke bawah lah. Okay. Then ln e. So another side will be ln 0.3. Okay. So ln e is 1. So I'm going to have negative t 4 to the power of negative 3 ln ln 0.3. So I use my calculator, ln 0.3. So I'll have negative 1.203. So 1.204 lah. So I'll get negative 1.204. So I can determine my time. So my time, you might pause the video to calculate the value. So 1.204 times 4 to the power of negative 3. So I'll get the time is 4.82 to the power of negative 3. 4.82 to the power of negative 3 seconds. So this one will be my answer. Okay. So after that, we want to plot the graph of Q against time. Actually, we are already sketching the graph. During we get the idea to calculate the time. So we sketch the graph. So the graph will be the graph for charging process. So Q is in coulomb. Time unit is second. So during the charging process, our charge will increase with time until it reaches a maximum value, increase exponentially. Okay, so this is Q naught. Then in order to reach 70% of our Q naught, the time will be, we already calculate, 4.82 to the power of negative 3 seconds. Okay, so this will be the sketching of graph Q against time. Then we have done with our question 6.